All right, we're live. Happy Friday. Unfortunately, I didn't get to stream on Wednesday because of unable to sleeping. Although I figure I could start today with a quick retro on like what happened and why I wasn't able to sleep because I did figure it out. At first, I had thought that it was due to me not being able to calm my mind down enough. But in reality, what had happened was I had a little bit of green tea after dinner, and I I know that green tea is it has good antioxidants and it's good for you, but I forgot that green tea has caffeine in it. Because previously I've just been having herbal tea, even in like the morning, I've been having herbal teas throughout the day. So I've kind of allowed myself to get off the caffeine bandwagon, and it affected me a lot. Couldn't go to sleep for a while. And I had no idea why like my brain was racing and like all these ideas were coming to my mind. And yep, it was caffeine. So let me set up the chat here mobily. I do have a question. So for everyone who is watching the VODs or watching live, um, regardless if you're on YouTube or on Twitch here, if you like, we're continuing on the nature of code, and I want to know your opinions on if I should do all of the exercises and all of the examples, or just the ones that sort of like feel good or sufficiently different from each other. So let me give you an example by coming over to Chromium. And we'll head over to the book. So if we go to the introductions to where we at, we initially started with uh, yeah, it was just the one. Random walk. So we did this one. Now, then we did random number, sort of like just showing the random number distribution. But then the next exercise is, well, I guess there's an exercise, there's a non-display exercise. What's the probability of drawing two aces in a row for a deck of 50 cards? That's also like, to me, it's a little bit, maybe a little bit more boring to watch because it's not as visual. Um, in fact, there's no visual part of that about that whatsoever. But here is another random walker. But this one is a more of a chance to move to the right. There's still a chance to move up, down, and left. It's just gonna prefer to move to the right. However, this is also similar to the other random walker. So I'd be curious to know, do you want to see these examples also done in Rust? Or should I go ahead and skip to the next sufficiently different visual one, which to me is perlin noise here. So I'm today I want to try to create this, which is basically, I wouldn't say it's a landscape, but it's a visualization of what perlin noise looks like as compared to random. So we'll do random first and then perlin noise next. So with that being said, I'm gonna go ahead and get started. But go ahead and leave a comment, tweet at me. Many ways to let me know, and I see all of those. All right. So let's do a cargo new. And do I want to do like a cargo new? I could also just copy. Might be good to just we could just copy I two. To what is this? I guess this is. They don't really have this as a full example. It's just more of like noise 1D graph. So that's what I'm gonna do. Noise 1D. Oh, and we need this recursively. Good morning, Chantilly. Welcome to the stream. And because I just sort of created this off here, VS Code updated. Let's go ahead and we have our library. We could empty this out. What's happening is I'm just getting started. I am planning on creating this, like these two graphs today. First this one, but then refactor it over to be this perlin noise to make it look, a little bit interesting. Let's see, so then we have implement game, so we have new, so obviously all new goes away, and we're just returning an empty game. Don't need a reset. We have these updates, so OK is going to be the only thing we have, which means context needs to be underscore. And draw is going to be the same thing. We're just going to have clear and present as our two things in there. And then in main, that means you, we don't need you. What's an OK? So in, we're returning this game result thing. And if you notice here, is this too small to read? Basically, we're expecting a return type of a game result, and the game result is going to have just an empty parenthesis, so like nothing at all. So parentheses are essentially tuple type, so a tuple with nothing. Not too small for you? Perfect. So this is just returning an OK type, which is a result, which is a subset of game result, with just an empty tuple inside. So that's all that's happening there. And then in main RS, we'll have to change this to like the names of that. Use GGZ. What I want to do is create like create something where I can just like copy paste this in, because this part is like what we want to change. So this will be, instead of random distribution, this will be perlin noise. And we want to change U2, so instead of I2, this will be noise. I'll just call this perlin noise. Purring noise. Make a cat simulator. All right, so that should be good for this file, and the library should be good. I have to underscore this because it's we're not using it. You'll need a cat when I do this function. Yeah, I don't have a cat. I have thought about getting one, but I also go off to work all day, so I don't know if a cat can. Well, all the cats I've owned in my life have been very like sort of social and wants to hang out with people, as opposed to just wants to be alone all day. All right, so I think we're good with that. I'm thinking, do I have GitHub logged in here? I do. Okay, so let's just go to gist.github.com, and I'm gonna create Okay, so this is going to be ggez basic setup. Oh, file name, this will be the main.rs. And there's that. I don't think there's anything else that I need to change here. I guess. Oh, this is not main.rs. This is our live. So live.rs. So that's fine. We'll add a file. This will be main.rs. And I am going to change this to game name. I'll leave it as this because I'm going to be using this most likely, but of course I'm going to create this as public. So if any of you want to use it, then you can just change that. That should be the basics for this one. And then the final thing is this cargo.toml. I don't want to like keep everything here, but specifically, like we always need rand, don't we? I kind of feel that rand is like a really big one. Oh, and isn't ggez 0.6 now? Good question. ggez. No, it's okay. It's 0.5 still. Never mind. Stacking. Good morning. A big one that's still not in a standard library. I know it's gonna be like the joke that we always mention until eventually Mozilla adds it in, or maybe they just won't, and this will be like their big thing forever. It'll be the joke. Like 20 years from now, we'll still be joking about how we have to pull in rand. All right, so I do have this for myself now, so I could just. Why is that? I hate that it's now librs. I wish like the description was a little bit better. Was like the thing that came in here. One day they'll randomly add it. Oh, I see what you did there. All right, so with that, we wanted to create basically do this first. So we're going to start with the like a spot in the center. We're going to draw a line to a random pixel, like 1 pixel over, and then that will just sort of like move to the right. I think that's what I want. The other choice is I could start in the center and then just like have it memorize all the previous pixels that's in, and then have them shift to the left. That could be an interesting one too. So those are two ideas to have, and that way it will just sort of see it creating. For right now, I think. Well, I could also have it start at the right and move over like that one. Let's start. We could just start in the center and have it like just drawing pixels up and down. And then we can refactor it to like move it to the left. Which of course does mean that we need that rand, which I think I didn't remove, so we still have it. All right. We need coordinates for where to bring it. We're going to start with an x coordinate. So in our library here, we could start with an x coordinate in probably the far left. This probably will be like a vector of these coordinates, of these pixels. That's what I'm thinking. So we could have, I guess we'll have our point, I can't call it points, call this random points. This is going to be a type vector, vec, and I'm going to put a point. So let's bring that in. Use ggz NA algebra point 2. So we're going to have a point 2, which itself is going to be F32s. And of course, to begin with, we won't have any at all. So, or actually, you know what? We're going to start with exactly at the center, aren't we? So we could do random points is a vec of point 2, not that, new. We do need to have like the center, so we could start. We could actually put this at the center it is. So we need to grab that too. So that's going to be let window width, window height equals, we'll need the context for this. So it's going to be graphics. Oh, you always remind me what exactly this is. This is like the get drawable size, I think. Yeah. Drawable size, and we'll add the context in here. And now this will be window width, window height divided by 2, so it starts in the center. So we're going to start with 0.0 of x and window width divided by 2.0. So that's going to be our first point. And can I draw just like a point to the screen? I mean, I know I can draw a circle, but I think I want to draw. Well, let's like, I guess for update, let's add a new point that's completely random, but we'll add one to this point, which means we need to track where our current x is. So current x is going to be just an F32. So let current x equals, we'll initialize this to 0.0, and we'll just set this to be current x. I don't think, so because this is a simple F32, I think I can get away with doing this because it's going to copy it, but I don't know. Maybe it won't. Maybe we'll try to give ownership to the point 2, and I'll need to like actually do the copy function myself. So far, it doesn't seem to be upset about this. Okay, so I can increment current x now. So in our update, we'll begin by incrementing current x. So we'll say self.current x equals self.current x plus 1. Then let's now draw, like we'll add a new point to this. We need a new random spot. All primitive types should have the copy trait. Yeah, that's what I vaguely remembered that. 1.0. So we need a random number between 0 and height. So that means we also need this window. So I don't know what the best practice here is. This is a copy of this. I wonder if I should just put the window width in here and window height instead of like grabbing every time, but I don't think it's a I don't think this would be a problem with seeing like I don't know what I'm trying to say. I don't think this would be a problem with like performance. I think it's because it's just grabbing something that's already there in static. I think it's more of I don't want to repeat code. So window width, so we can now add in a window height and a window width. Yeah, keep it dry. So we have that there. And now we need to get the rand functionality. So that, wait, do we, rand rust length. Right, so then mute range. I guess like I can create this directly in the library, right? And make it private? Or would it be better for me to put this on the struct? Katali, hello, good morning. What I'm worried about is whenever I try to put something on a struct like this, would I need to would I need to put something else on too? Oh, like the lifetimes. I would need to like give lifetimes into it. I don't know. Let's try it. See if that's still the case, or if I'm just wrong here. So let's go ahead and bring in the prelude, and let's get this RNG. So we'll get the random number generator from here. What am I building today? So today in Nature of Code, we're building this. So at the very beginning of the video, I did ask, and so like that's mostly for the VOD viewers. But should I be going over all the exercises in Nature of Code and creating Rust sort of like solutions for them? Or should I be doing it only like for all the examples and exercises, just the exercises, or just skip and do ones that are sufficiently different from each other and are more like fun to watch? So there was like a bunch of other random walkers that are like very similar to each other. There was one what's the percent chance that like a certain card will be picked from a deck of cards, and it's like that's not even visual. So I'm skipping over to perlin noise and like this type of random generation visualizer. So you all can vote right now. And by vote, I mean just tell me in chat. Okay, so we have that. Let's grab this here. So we're going to get the random number generator. And what type are you? Your type thread RNG. So you vote for the second option. Which option was that? Just do whatever I feel like. Yeah, okay, cool. Then well, at least for right now, I'll continue doing that. We'll do RNG. I am very like I don't think this is gonna work, but let's try thread RNG. Missing field RNG, okay. Okay, so it's not yelling at me. I was kind of expecting it to say I needed lifetimes set up. But that's cool. So I'm storing RNGs. Now, right here, I can use RNG to generate, I want a number. We're using 2018. We don't know what lifetimes are anymore. What? Oh, we're in the future? The future of Rust? Oh man. All those great articles that I read about how random, how like lifetimes worked, and then still got confused by them. All right, so I want to see like, I think it was gen. I want to see the other uses of gen. Okay. No, wrong one. Gen range. Generate a random value in the range low to high, inclusive of low and exclusive of high. This function is optimized for the case that only a single sample is made from the given range. Oh, okay, so I need to use uniform. So distribution's uniform. Oh, interesting. So they let between equals uniform from. I do this before I get the random number generator. Then that mute sum equals 0. Okay, so then oh, so this is gonna grab. I don't like. Eventually, I want to do this infinite number of times. So I don't know if this is like the right way to do it. Maybe I should just stick with get range for right now. So we're gonna get range between low and high. So let this is gonna be our random y equals self.rng.get range. Our low is going to be, well, I guess our low is going to be current. Oh no, just like it's going to be 0.0, and our high is going to be self.window height, because we're just getting the random y here. Oh, no method name get range for self RNG. Oh, I gave it the wrong type, didn't I? Because like I'm passing in RNG, so I have access to that, but I told it there was another type. Because that should work. How can I see what RNG is? I guess it was the thread, right? Thread RNG. Oh, the other one. So it returns this thread RNG. Huh. When in doubt, let Rust tell me the type. Okay, I can definitely do that. I can remove the type here. Heck, I could do this. I'll just tell it's a string. and it will then say expected struct string found struct rand rngs thread rng. Well, okay, so that's kind of what I was giving it, I think. I mean, I'm think it's coming from prelude, because when I give thread rng, it finds it, and that means that prelude is going to be used. But now this RNG doesn't have get range. You know what? I wonder if this is just one of those RLS isn't able to figure it out things, but Rust, like the actual compiler, will. Oh, get range. Haha, gen range. You're right. Wrong key. Thank you, Stacking. I should turn this on. There, well, okay, so that worked. Clearly that was just me being silly. So now we have our random y, we've incremented x. We can now create a new point. So let new, so our new point equals point two new. It's going to be our current, or self.currentx. And then the y is going to be our random y. And then we want to now add in so this is going to be self dot random points dot, we're going to push in here our new point. You spent hours debugging typos? Yeah, I have too. It's one of the best things about like streaming on Twitch here is that I get all of you to help me program and point out all these errors before they become hours and hours. Is there a linting tool? There was, and it was telling me that I had completely misspelled it, but I was just not believing it, which is probably my fault. All right. So this is creating like a bunch of points across the screen and just moving to the right infinitely, which is great. I can also like eventually make everything move to the left with this, but I'm not going to worry about you right now. Your does not need to be mutable. Interesting. I'll deal with that in a little bit. Window width is not being used either. I guess let's try to draw this to the screen now. So we're gonna start with the first point. Is there a point draw on GGEZ? Like, I mean, see, that's rectangle. Yeah, I don't see that. How about a line, or do I have to use like a mesh for that? Create a new mesh for a line. Of one or more connected segments. Well, okay. So I could just loop through our entire our vector and just hand it all these points, which I have. So I can just essentially hand it the full slice. Renon MO, good morning, hello. And it should draw the lines? Is that? Hey, take me back to where it was. So let's try this. This is new mesh build. So I guess mesh builder for everything, including lines. That's cool. So that mesh equals new, and then we'll do dot line. I'm gonna move this over to the right so I can see it better. So in draw here, I'm gonna say let they're calling this mesh. Oh, I see. Why are they doing this one 3 times? Oh, they're drawing the same thing 3 times. That's what it is. So I think I'm just gonna call this my line equals graphics mesh builder new dot line. And so inside of here, I need to give it a reference. I kind of already have a reference here. So can I just do self dot random points? Yeah, so far. What's this 1.0? I guess, yeah, they had a line there. So you have points. Oh, the width. How wide is it? Let's try 1.0 and we'll see whether or not that is, I'm gonna actually give this a variable here. That way it's a little bit more documented. Do people actually find multi-line arrays easier to read? So instead of doing, well, I guess, oh, this isn't, I'm doing this wrong. I'm not supposed to have closed this. So like that. So yeah, I see what you mean. Like whether or not we want to put, well, this could potentially go on a separate line, but this one here and this here. I think people try to do this to like stay within 80 character limits for some arbitrary reason. I need a dot instead of the comma. Right here. So I have dot line, self dot random points. Nope, I think I'm good. So then line width, and then the color. So we'll just say let color equals, oh, awesome. So give me graphics and white is fine. And then we need to handle this. So we'll just do that. And then build. I need a build. So dot build. We hand it the context. And then we have to handle that result. And now we can do semicolon. Oh, this is interesting. And I still haven't figured out like the proper way to do this. I keep on forgetting that we give the location 2 times. Also, you need to be a reference, so I'm just going to give you a reference to the vector, which is now a slice. I need to now draw this line, and I've given it the points to draw here. So I'm kind of curious of like, where should I be giving the points here? Should like this be 0, 0, 0? I'm actually not sure, because previously I was just giving 0, 0 and just moving it with draw to like wherever I want it to be. So graphics, we're going to draw and the context. The drawable, so this is going to be a reference to the line. Our params, so this is a tuple. Which right now only has the location of where I want it to go. What you? Oh, you're tilted. So that's the tilt amount. And I don't know if they have, if this enum is implements copy, so I just won't. I'll just do this. Okay, so you need, I think, a point in here. So 0.2, new. So let's try 0.0, 0.0, and just starting in the top left. Also, what did I do wrong? This function takes 3 parameters, but 5 were supplied. Oh, yeah, this is all in the tuple. That's the problem. Okay, so if I save that, let's run this, see what happens. Oh, I thought by copying it over, it wouldn't have to compile everything again. Because I didn't install anything over. I copied all over the binary files. So that's too bad. It does feel slightly faster. But that might be just because I'm not having this computer stream at the same time, so it's like got less to do. Okay, so it is complaining that the variable doesn't need to be mutable. Hey, look at that. So it worked. And we saw it like sort of draw all the way over to the right. So perfect. Kind of the next thing I want to do is maybe start on the right and have everything move to the left. So what would that look like? Did I? Yeah, I did quit it. I don't want that running in the background and like just forever. So if I start my current X, this is now always going to be at window width. So we're always going to be in the far right. Apparently you don't need to be mutable. We're not using you, so I'm gonna, although I might in the future. I guess you're being used. So if I'm storing you, this will just have to be underscore and then window width, like that. Okay, so I'm now doing this on the far right. I don't need to increment current x, so that will always stay the same. But what I do need to do is, because I'm drawing all these lines, is shift all of the x's over by 1, which means I need to loop through the vector and mutate each of the points. I think, does vectors implement map, right? I think I can do that. That won't do it in place, though. That will give me a new one. So would it be better for me to just overwrite these points with a new one? So before I add a new point, I want to mutate over. So this is going to be self.randomPoints equals self.randomPoints.map. No method name map. Oh. Right, my random points is a vector. So why is it no method name map for, centered vector of this type? Huh. I thought it was going to be a generic. I'm probably just looking that up wrong. Let's go to actually the Rust Lang documentation. Where's... Oh, I guess I should really just search for a map. Okay, so take a closure and creates an iterator which calls. Oh, so I have to turn... Okay, so I have to use iterator to convert the vector into iterator, then I can call map on it. And then I can use a closure inside of there, or iter mute. Ooh, iter mute. If I do iter mute, and then I map through, would that be map I want? Oh, I could just do this then, for element. So I won't need to do map. I could just then. Okay, so this is a much better method of doing it. We'll just mutate. So in here, we're just going to do for random point in self dot random points dot iter mute. You don't remember map being an iter? I mean, it sort of showed in documentation, but yeah, I don't know. I haven't been paying attention, so I don't know if that's new or not. So now I can dereference the element and then grab that. So we're gonna say dereferenced random point dot x. Right, because it's just a point, so it's the current one equals. I wonder if I'd need to dereference here too to grab this value. -1. dot 0. Type, oh, F32 cannot be dereferenced, so I don't need to. Well, so let's see if this works. I'm not incrementing, now I'm de-incrementing all of the x's, moving backwards, and I'm creating a new one at the far right. So I think that should work. Yeah, so perfect. We now see all of these random numbers being created. Now, of course, we have a problem. You notice how it's slowing down because I'm not killing any of the numbers in the far left, and I'm still attempting to draw them. So I have like just a very minor memory leak, which will just take over the entire computer and crash it eventually, or at least crash the program. So we should fix that too and remove the ones that are no longer on the screen. So what options do I have for removing items from a vector or from a slice? So this drain creates a draining iterator that removes the specified range in the vector and yields the removed items. And of course, drain filter. And a full range clears, okay. But of course, this is simple. So because I have, oh, nightly only experimental, so I can't do that. I don't think I can put drain in here, right? Because would a point be able to be equal to a point? So it's going to v dot drain 1 dot dot collect. So u is now going to be 2 and 3. Oh, so it's going to drain everything other than that. That's not what I want. If you compare the x of the point with the window's width, you should be able to remove it. Well, yeah, I figured I could remove it. I guess like, I'm wondering if there's a, like what method to use to remove it. So there's splice. I don't know if that's what I want. There's remove. That just removes element at position index. Yeah, so I guess I'm not completely certain which method I should use. Oh, interesting. Drain is a structure. What do you all think? What It's not a dedup because they're all unique with that x value. So we have x. Do we have, oh yeah, so remove just removes it from position. So, I mean, I guess I could find the position and then use remove for that. Drain potentially works, except I think it's the opposite of what I want. It removes the specified range in the vector and yields the removed items. Is that a range of indexes? It doesn't look like it because it's removing like one ... like one through everything else. Oh no, it is. It's a range of indexes, so it's draining all of these. So that's not what I want either. Drain filter would be nice, but this is nightly only. Remove is by index. If vec length is greater than window width, just pop off from the beginning. I could see that working. I mean, it's an assumption that, I guess because I'm only moving by one full pixel to the left, then that should be right. I kind of want to find like a more defensive way to do it, but if like a more exact, like to make sure I don't, it doesn't, like the wrong way it doesn't work, but I could definitely see that working. No, I don't want to swap remove. Well, I guess let's see that. Where does pop? So then this is the other problem. Popper removes the last element from the vector. Is there like a shift which removes the first element of the vector? I mean, if I just do remove, shifting all elements after it to the left. Okay, so I could just remove the first element every single time. So what I could do is after we've added all these things in here, then we'll just do a quick check. So if self.randomPoints.length, if that is greater than self.windowWidth, which now, okay, so now this needs to be not underscored, so we can change that to be there, which means you can be like that again. Okay, so if you are greater than window width, then I want you to just remove the first index. So self.randomPoints.remove index is going to be 0. You return with a type. Oh, removes and returns the element of position, so I don't really care. That. Mismatch types. Oh, okay. So because your length, can I do dot into here to convert the length into an F32? Oh, type annotations needed. No, so I can't. I can do as. Okay, so if self.random points dot length, so if the length of this as an F32 is greater than window width, which already is an F32, and I wonder, like, should I actually convert this to, like, would it be better to convert this in? So as, what is this, a U32? U size. Then I'll just remove the first index. I don't really care what happens to it. So I wonder if this will work. Now we shouldn't see it slowing down. We don't. So perfect. Excellent. First part of this challenge is done. We are creating a whole bunch of random, sort of like just random lines. Now we need to research. Is there, because I haven't actually looked up, is there a perlin noise? Oh wait, that wouldn't be in here. That would be in rand. Because of course, nobody else has access to that. So, perlin. Ugh. I don't know. This might not work. This might not work because I may not have access to perlin noise. We could look at the Rust Rand book. No results for that. So is it just completely Blender? I haven't looked. Blender Rust line. Wait, is Blender not a crate? Oh, you're asking if that noise is a blender. No, that noise I think is my fan. I might be able to turn the gain down on the microphone a little bit. That might help. I think it did that correctly. Also, I'm gonna check to make sure I'm not, like, I'm only listening from this side of the microphone, because I might have forgotten to change that back. Oh, I need to use this mouse. Yes, I did. Okay, so I was listening to, like, the entire room with the microphone, and so it was catching up. Is this better? I hope it is. I was kind of hoping you were telling me there's some crate that has, like, a better, like, it has perlin noise, but I guess not. So far you don't hear it. Perfect. Well. So there's weighted. I don't know enough about random numbers to, like. So I mean, from what I understand of perlin noise, and the book does go into it a little bit. The idea of perlin noise is that it's like a graph that's at a time. Oh, you did. There's oh, noise itself. It's like that's a completely different. Well, let me also just check rand for noise. No. I mean, that doesn't look right at all. I don't even see where noise came from in this. But let's do wrestling noise. Yeah, so look, perlin. So new. A procedural noise generation library for Rust. That sounds exactly what we want. All right, this is cool. We need 2 random libraries in this crate to do this. What version are you? Your noise 051. Or so 0.5. So I guess I'm gonna first create a commit here. So random numbers working. And so now we're gonna add in noise equals 0.5. Huh, same as GGZ. I wonder if that's a coincidence. So use noise function in perlin. Let perlin equals perlin new. We're going to get a value, perlin.get, and then it's going to be an array slice of these numbers, and that's it. I want to take a look at perlin. I want to see that perlin get and to see like what it's really doing. Where's get? Okay, so types of that. I thought get was off of perlin. That's format. Okay, hold on. Oh, yeah, so perlin.get. So perlin struct has a get implementation on it. You think they're doing something related to dimensions? I mean, so to me, it doesn't make sense to be getting dimensions. To me, it makes more sense that they're getting it based upon the time index. So there's this entire idea of in perlin noise that it's really just this graph. And the more, like if I'm just doing a single dimensional graph, then I'm just like, okay, time index here. And then if I just move forward by like 0.01, then it's going to be a related number. If I do like a big jump like this, it just looks random again. But you can get multi-dimensional perlin noise. So it's not just like a single number, but like an entire field that they're kind of sort of related to each other, but not really, as far as I know. That's where sort of like knowledge breaks down a little bit when we're going like past just a single dimension. But like, is val multiple things? Like, I would almost imagine that it's multiple, but I don't know. I need to go to perlin struct. And then I need to find the implementation for perlin for get, but I only see new here. Huh. Okay, so here's like 4-dimensional perlin noise, 3-dimensional perlin noise, 2-dimensional perlin noise. I guess I probably want that because there's not going to be a get for anything else. So I keep missing it. Struct perlin 0.60 0.2. Well, is this noise function, isn't it? Noise function of 2D. And here's our get. And it's just a point. Is it a point on the line? I want an example. Where n is 2, 3, 4. Wait, where's n? A noise function is an object that calculates the outputs of value given an n-dimension input value where n is 2, 3, 4. Each type of noise function uses a specific method to calculate an output value. Okay. So I get a point type that's generic. So that's interesting. I can also, so this is the traits. Let's go see how it's implemented. In point. So we're going to go back to our source here. And we're going to look for that 2-dimensional. So get. Oh no, it's a F64 point. I don't think I can convert an F64 to an F32. Is there a way to just say I'll convert and just lose everything off of the end? Just like contain it within its amount? Okay. So we could try this. You wonder if I can upscale and fill everything else with zeros. Well, I can't upscale because GGEZ requires F32, so I need to downscale and just lose data, but I'm okay with that. Katali, you suggest casting between types. So let's look at that. Slang casting between types. Why would you take me here but not take me to what I had searched for? Sure. Search. I guess scalar types. Not integer. Floating types. Am I still in the wrong version of the book? This is the latest version. Because we are on 1.8, this is 1.30. I guess Google sent me to the wrong version initially, but then I clicked the button. Okay, so wait. Oh, so it's just talking about these. I need to change between. What? I mean, you're just telling me about the different types. Okay, I get that. Where's the casting part? I did not. So I don't see. I don't see where it's like saying, okay, you can now convert and lose data. Let's try just a general Google search. Rust lang. Cast F64 to F32. X64 cast seems to lose too much precision. You lied to me. Okay, so you're suggesting just try to use as and like just see if it works. What was that Rust playground? Play.rust. So let's see what we could do here. So if we have let my 64 equals, and I want to explicitly state that this is an F64 equals, like, I don't know, like something like that. I don't know if that's too big. It might be too big. So let 32, which is an F32, equals 64 as F32. Ah, okay. So it ran and it just converted it down. Should print both to check? Yeah, that's a good idea. So here's our first one. Oh, I don't really need you. And I don't need a space. So we only had So this is the difference. So it works. Like, it technically works. So I guess we don't have to worry about it too much. So let's go ahead and grab this library in. So we already put the use, like, the noise. So we just have to use noise. And we need to get perlin in here. I think we want to now add you in. So perlin is type perlin. That perlin equals this, and add you in there. And then we're going to do a get. And I think I only need to grab one value because I'm just getting a 2D array, like a 2D perlin noise, instead of 4D or a 3D, whichever one this is. I think that's how it is. Unfortunately, this doesn't really give us much like better explanation. Is there like a website that has better documentation? Not really. This isn't really telling me anything about how to like specifically get small points. What if there's issues? One-dimensional noise module implementations or n-dimensional. I wonder if there's a pull request for like documentation. No. Okay. Never mind. We'll just let's just try it. Let's see what can happen. Okay, so we have perlin. Now what we can do is we're just gonna do this example is different. Interesting. We can do perlin.get. Bix plays, hello. Welcome back. Perlin.get, we're gonna give it a array slice. And then we're gonna have to increment this array slice, I believe. So let's add this in here too. This seems to be like, what does, let's go back and find out what it needs. So implementing get, okay, so it's a point. It's a 0.2 of F64. 0.2 is from math. I hope that this works the same with NA algebra. Don't expect it to be a regular. Oh, that's fine. I fully understand. It's just more of this is when I can. So, this needs to be a point. So, what is this calling? I think oh, they call it like nature of code like has a name for this variable it's called, and I forget what it is. Oh, X off and Y off. So I could try that. I'll just name it our X off. I guess it's gonna be the Y off, isn't it? And this is going to be a 0.2 of F64. Well, awesome. Well, I'm glad you stopped by. Okay, so Y off is 0.2 F64. Then we have to set this to be something. I guess we can set it to be 0. So we'll just sort of say let Y off equals 0.0. We'll set that there. Down here we need to increment, so we'll use Y off. When we get the point. So NA algebra F64 point. Wait, 0.0 isn't. Oh, right, 0.00. Oops. 0.2 new 0.0 0.0. That's what we're gonna do. Then I need to grab this perlin noise. So perlin.get and random points. This new point will be based upon this. So let perlin random equals self.perlin.get, and we're going to self.y off. The trait bound noise is not satisfied. Okay, the following implementations were found: noise, FNS, generators, perlin as noise. Okay. Yeah, good. Definitely good luck reading this error. Okay. Now, is this because I'm using NA algebra or N algebra points and not math points? So I need to use where can I see what it's using? Dependencies, just image and rand. Use gradient and math. Wait, does it have its own point system? Okay, so 0.2, a two-dimensional point. This is a fixed size arrays. Wait, so do I have to implement with theirs? Because like all these trait implementations, is that what I have to do? This is off of noise 0.2. So hold on. 0.2. I'm okay. So they have a type point two. I don't think I've played with like just creating types like that. Is it? I mean, it's a structure, right? Okay, so point equals, and then square brackets t, so generic number type, and then 2, so there's 2 of them. With this, what fixed size? Oh, it needs to be an array. That's what the problem is. So it needs to be an array. So, okay, y off is not going to be a point 2. It's going to be an array. How do I give it a type array? Because like it's not like array, right? Or do I have to create a new type based upon this? And then y, oh, y off. I guess this would be F64s. Okay, so I guess I could just do that. And then in here, so y off is going to be 0.0, 0.0. Semicolon. So doesn't have a size note and compile time. So is that where I can do something like comma 2 to say like I want it to be of size 2? No. Expected 1 of. All right, so let's, I guess, oh, semicolon. Okay, so we're saying that y off is going to be an array of 2 things, type F64 and 2 of them. So here are 2 F64s, we're just 0.0, 0.0. We're then trying to get perlin noise, and we're getting self off. Okay, so no errors anymore with this. Unused variable, it doesn't tell me what it is, like type wise. Oh no, F64. Okay, so it's an F64. And now I want to set this new point, which is going to be self the current y, and this is now going to be perlin random as F32. We don't need u anymore because we're not getting a random y. And then I need to increment our y off. So down here, let's increment our y off. So this is going to be self dot y off of position 1 equals self dot y off position 1 plus 0.01. So it's like a smaller jump up. Let's see if this works. I have no idea. It is running a little bit late, so I don't know if I'm gonna have time to like debug this if it doesn't work. So let's like hope that it does. Yeah, it said that it works with most libraries. Okay, that's interesting. Like it. Okay. What happened at the beginning? I missed what happened at the beginning. It just is a number and it just goes straight to the top. So that's something. Weird. Yeah. Um all right. One thing I can try is in this noise. Nope, not all docs. Noise. It does have this as the size. So I wonder if this is like the upper and lower bounds. I think one of you maybe mentioned that it could be. So I could set this. I could set this as, instead of, I guess I'll just continue doing this y off. This will be 3 now. Maybe instead of y off, I'll just say that this is the perlin bounds. And so we're going to start with the upper bound, which is going to be 0.0, and the lower bound, which is going to be window height as F64. And then we're just going to start with 0.0 as like the incrementation of it. I'm guessing that's how that works. I don't know. And then we're going to move down here. And so instead of position 1, this is now 0, 1, 2. And increment that, but keep the others the same? I don't know. Let's find out. No. I mean, it's more consistent. There's no dashes in between them. Line 54. Self perlin bounds 2. Oh, yeah, this needs to be self perlin bounds 2. All right. Good catch. I don't know if that's gonna fix this, but let's try it. No, so like it's just going straight to the top and just like going along it. So unfortunately, we don't have enough documentation in this noise library to really see how we're supposed to be getting this. Because I wish there was a little bit better. I don't need you still running. Okay, so fractional Brownian noise. So I don't know what that means. Hybrid. I guess there's a lot of like subsets of perlin noise, and because I don't know what those are, so I don't know which ones to do. There's this perlin noise function that outputs 2, 3, 4 dimensional perlin noise. I guess like the other problem that I have is I don't want 2-dimensional. I want a single dimensional perlin noise. Like that's another issue. What if I need... Well, so how do I say that I really only want two-dimensional? So I have new. Oh, so it just depends upon whether or not I handed a 0.2, a 0.3, or a 0.4. Okay, so if we have this is a 0.3. All right, so let's try to rename this back to just perlin. What is this called here? I guess like a perlin point. F64, we'll just do the smallest one, 0.2. We can start these both at 0.0 and 0.0. And then down here, let's implement both of them. And so we'll just increment both these points by the same amount. Oh, right, you need to be 0. Yeah, we're getting the exact same problem. It just goes straight up to the top. So our F60, or our number that we're getting out is... Wait, is this a number between 0 and 1? Is that what we're getting? Is a number between 0 and 1? Do I need to scale this up? So we get our perlin random. Do I need to multiply this by... Okay, so as F32, and we're going to immediately multiply this by self.window height. I don't need to convert it again here. Hey, a little bit closer, a little bit better. That almost looks like it's starting at 0. Yeah, perlin noise like kind of sort of looks like it has a pattern to it. It looks more natural. And the lower I make that incremental change, the better that's going to look. So what happens if I don't increment one of these, like the second one? If I just leave this alone, will that change how it looks to it? At the beginning, it sort of went, oh yeah, it kind of does. It makes it a little bit less random. So I guess I do want to have this incremented. I could add some zeros in here. This will make it smoother and longer. Do I want to double this? So like go all the way to the bottom. What we were hoping to get was something similar to this, which is like, okay, I always want the x to be at the far right 0. And then I want the y to be going up and down, but based upon 0. So if I want you to start at 0 and I want to add or subtract from that, is that would that be how I can create this? Well, I really want to just choose a random number between here and here, but based upon perlin noise. But right now, it's kind of looking like it's going way up to the top. So what if I double this? So times self.window height itself times 2.0. I mean, it's kind of almost working. It's going out of bounds a lot. I wonder if multiplying it isn't what I want to do, but like also adding to shift it down. So what I guess what are its bounds? Is it between -1 and 1? So in that case, do I need to add 1 to it first? So self.perlin.get, we add 1 to it. Yeah, hold on. So I'm getting this a little bit crazy. Let's reset this. So we get a random number, and that's our perlin raw random number. Then I want to add 1 to it, so it's between 0 and 1, not -1 and 1. Oh, I guess it'll be 0 and 2 then, wouldn't it? Let's actually just print this out. So we have perlin random. I'll make you as F32 again. So this is going to be just at the top, but let's actually print out. So where's that debug? Perlin random. Let's see what we got here. So I am seeing numbers between -1 and 1. And that's it. There's just F64s between -1 and 1. Okay. So by multiplying it, I'm scaling it out, but it's like way the wrong one. So I want to scale it by half and then add by half. And that will put it right into the middle of the screen. So I want to take this perlin random. Let's just immediately convert it to F32s. So I'm going to call this random raw. Perlin random is now going to be, we need to scale it up by half of the window height. So perlin random raw, we're going to multiply it by half the window height. So self dot window height divided by 2.0. And then we need to add, so then we're going to add half of the window height. So self dot window height divided by 2.0. I think that'll put it right into the center. Oh, and I don't need to debug anymore. Wait, I'm not debugging anymore. No, not open up code. Cargo run. Here we go. This is what we were hoping to get. So these are always super fun to watch because they are random and they look like they have patterns to it. So they look a lot more organic and like more real. And it's because of that graph over time. So it generates this graph or this plane, and then based upon our time grabbing, so every single frame we're saying like get 0.001 of the next spot, and that number is related to the previous number. If I decreased down our y off, so we increased by like 0.00001 instead, it would be a much more flat and smooth surface. So this is how I think some games can create their terrain. And if you want mountains, you just decrease the y, or yeah, you increase the y off so that it's more jagged. And if you want flat plains, you increase the y off. I think that there's a lot more to it, obviously, but this kind of looks like just random hills, doesn't it? But this was the challenge that I was hoping to do. So I'm super happy that we eventually were able to get here. Does anybody have like thoughts on this, or like better ways that I can do this? Using perlin noise to generate the random lines. It's really cool. Yeah, perlin noise is really cool. The book does have a warning section on it. It basically says once you discover perlin noise, you want to use it for everything, and that can actually make things look less real. You're ready to move to Colorado now? It's really hot here, so I don't know. It's also like apparently you can't breathe outside because it's all the news channels are reporting that it's extremely what is it? The allergies are like extremely bad right now. But besides that, we have a good programming scene, so you can come hang out with all of us. All right. Well, with that, we are a few minutes over, but it's okay. It's Friday. I work from home on Fridays. So the next plan, I still have that like sort of like the vote out for everybody else who's on the VODs, of whether or not we want to do all of the exercises, and or you can't say there's hot. It's been all more than 30 degrees Celsius. Okay, fine. Yes, it's not as hot as Europe right now. That is true. It just felt really hot in the sun. Um, but I wasn't lighting on fire when I went outside. So there is that. So anyways, there leave a comment. I already have some of you live on a VOD, so I know that your votes are for just sort of like do the interesting ones that look interesting and are like sufficiently different from each other. But if you want to see me do all of them, let me know. The voting will essentially close probably after the weekend. So I am not like if you see this video like a year or two, I will not go back and create them all again. With that being said, I'm gonna go ahead and bring the stream to a close. So thank you everybody for watching. I'll see you next week, next time, and I hope that you have a great weekend and a great rest of your day. Bye.